So if I go to this initialization, I can start spelling out some of these things. Self.name equals str name. Might be nice to spell out the starting balance when you create an account. So since both of these are going to have a starting balance, I'm just going to go ahead and add that here. So I'm going to add that self dot balance equals sto fl balance. There we go. So we'll start there. So deposit. If I'm creating a deposit method inside this bank account, it's going to just be, now I can decide whether I want to handle the UI stuff in my class or if I want to handle that outside of my class in my main program. I think I'm going to do it inside the class because it makes the rest of the program really clean and easy to follow. You could do it outside the class just as easily, but I'm going to do it inside. So I'm going to say equals, let's say, input, how much do you want to deposit? Okay, and then I'm going to say self dot balance plus equals FL deposit. So I'm going to add that into self dot balance, and that's that. Now, this is fine. It'll work as long as somebody enters a number. If they enter something that's not a number, it's going to throw an error. So inside here, I'm just going to do ask for forgiveness type of situation. So I'm going to try that. And then I'm going to catch. No, accept. There we go. Wrong language. Try and accept. Print. Well, that didn't work. Okay, so now I've basically covered myself. If they input something that's not going to work as far as adding to it, no big deal. It'll just give them an error and send them back through the loop. There are probably more user-friendly ways to handle that, right? Um, but this is a simple way to make sure my program doesn't crash on me. Now, if you're thinking, gosh, I could probably use a lot of my previous code, you're absolutely right. So if I want to go into here, well, that one doesn't have what I need. Let's see. A5. I was hoping I would have a, let's see. Nope. Nope. Oh, well, I don't have any old ATM code, but if you have old ATM code, especially if you built it into functions, like you can really easily just pop it in there. But this method, again, if I'm doing this, I could just say something like check balance to see if enough, and then subtract amount, right? So first thing I need to do is to say, is the account. Now the nice thing here, I'm going to add, the nice thing here is that when I'm withdrawing, I don't have to specify which account I'm checking anymore. I just use self.amount, and it knows which one I'm referring to because I'm referring to that account. This is one of the benefits of having a class rather than having a method, because previously I would have had to feed this the account as well as the amount to check it. So if self.balance is greater than or equal to amount, then we're going to subtract so on the deposit, I don't need this, by the way. I just realized, because I'm asking for it inside. If I wanted to do the asking for input outside the class, then I would ask for that as I would use that as a parameter. So I don't need this either, because I'm going to ask in here. Okay, so I'm gonna get that amount, FL withdraw, and then okay, so again, I'm going to wrap this in a try and accept. So if it's enough, I'm going to subtract the amount. Self.balance minus equals FL withdraw, else. So if they don't have enough money, but it was a legal number that doesn't generate an error, then we're going to say print you don't have enough money. And then we have to close out the accept. With an error message. Okay, but that is a pretty easy structure to create, because we're just getting the input, we're checking the balance. This whole block is protected. If there's an error here or if there's an error here, it doesn't matter. It'll just skip straight to that part and move on. So it's a pretty robust class so far in terms of what we can do. So check balance is pretty easy. It doesn't even need any parameters. It's just basically printing the balance. So your balance for self.name is self.balance. And there we go. Now, using some of the other stuff that we've learned, I can also spruce this up a little bit, right? I could use the string and that is a return, not a print. It's going to return this. F string name and If I want to, I could say self.balance and I can justify that at 30 and use the period as a lead. Let's adjust this. I'll just 10, 20, comma, period. Now this thank you. There we go. Now this will, whenever I want to roll through the accounts, I can print them very easily. So that's all part of this. And I could even have a type in here that's generic that then gets substituted into this, and or the print line that I can override for savings and checking. So that would be, actually let's just do that. I'm going to add self.type equals, let's just say generic. So self.type generic here, I'm going to have that print here, self.type. Now the interesting thing here is that even though I'm doing this, when these inherit it, if I override the type, it's not going to say generic there, it's going to say the actual type, even though that method is defined elsewhere. So name and balance have to be for both of these. So I'm initializing the parent class properly. I want to do that here too. Okay. And then once we've initialized the parent class, I want to set the type. So let's go self.type equals savings. And down here, self.type equals checking. Okay, you also notice that I have already put in the check number here, self.check number. We're going to start each account at 1,000 when we create it, and then it'll go from there. When we write a check, we're going to increment check number by 1, but we also need to use some of this here because a withdraw is the same as a check, except it's a little different. So I'm going to steal this code, and I'm just going to modify it down here for write a check. Write a check. Want to write a check for, not the greatest English, but I'm just going to go with it. And then if there's enough, it will allow me to write the check. So right in this box, I'm going to say print check number self.check number for self Oh no, we're going to use FL withdraw for that. FL withdraw. Okay, so there's that. Now it's going to say that I wrote a check. Probably up here I should say I withdrew the money too. That would be a good thing to do. Print, you withdrew Okay, so there's that. And the interesting thing here is that bank account is the big class. Savings doesn't really do anything that different. Savings is just a generic account, but we've changed the type to savings. And then we have a checking account. Checking account has the right check, but that was very similar to a withdrawal, except that it has the check number. And that's pretty much the only unique thing about the checking account, except that it also has a check number. So now if I want to show accounts for for object account in LIS accounts, print OB account. Because up here we did this string, and that should take care of it. So I can print the objects because I have that set up. So if I want to create some starter accounts, right, I can create checking and savings by adding those or appending those to this. Where's my classes? Savings account, checking account. There we go. That's what they're called. There it is. Savings account. And now we have, what are we giving it? We're giving it a name and a balance. We give it a name and a balance for either one. So name, my savings, and the balance is $4,000 because we're feeling good today. So if I want to add a checking account, LIS accounts dot append checking account, and we're going to say main checking, and we're going to say $200 in there. Okay, so let's fill in the check balances here so we can just try out one of these methods and see how we'll kick the tires a little bit here before I turn you loose. I'm going to use the show accounts methods. Show accounts, LIS accounts. Okay, that should do it for that part. All true. We're going to loop forever here. Or not. Oh, that's because I ran the wrong one. There we go. Okay, so I created a couple of accounts just to try things out and get me started. So if I check balance, okay, so there is my account names, my savings dash savings with a type, and then 4,200 overridden. They're not lining up because I think I didn't allow enough spaces here, but you get the idea. And that's how I am going to interface with those objects. So once I have those objects created well up here, it's really a matter of just going one by one and saying, okay, how do I make a deposit? Well, I'm going to have to list the accounts. And ask which one. We're going to use the same enumerate loop thing that we did with the library or with our last set of things. So go back and look at how that was done. And then we are going to, we're going to call the deposit method for the chosen account. And that class, the nice thing about writing all of the logic into the class way up here in bank account, where we have the deposit defined, is that we can the deposit's defined there. All we do is call the deposit on that object, and then that class is going to take over getting the input, processing, error handling, all that stuff happens in the class. So we don't really have to worry about it. So if we're going to show accounts, or we can enumerate them, I'm going to let you pull that logic from the previous account. So we're going to enumerate the accounts, ask for which one, and then just call the deposit method. That should be it for that branch of the application. Same for the withdrawal. You find out which account, you call that object, so that instance's deposit or withdraw. That should be it. The trickier one is going to be the checking account or writing a check, because you can't just list all of the accounts, because you can't write a check against a savings account. So you're going to have to figure out how to only show checking accounts. I'm going to let you puzzle with that for a little bit. But I think that is a challenge that is doable. You just have to unpack it a little bit and do the logic. So we've got a relatively advanced application here. But once you have all of these things written, the actual application, the actual program logic with the menu structures and using those classes is pretty small. So this is a good distribution of taking those programmatic functions and pushing them out to a class. The nice thing about this is that it's using inheritance to handle everything that all of the accounts have in common. You might have a third type of account called investment account, where you have a deposit, withdraw. It might accrue interest or pay dividends or something like that it does something else. But that would be pretty easy to make. You just create another subclass, and you can still take advantage of all of the original class features. So that is Module 5. It is the last real hardcore assignment for the class. So hopefully we can get through this, and starting next week, we're going to start having some fun. I think we do images first and then a graphical user interface application. Yeah, I think that's it. I think we'll start with image processing in Python next week. So that's a lot of fun. Anyhow, you have about 30 minutes to play with this, and we can go from there.